to be here. So my name is Sacha Ahnen, as already said. I'm working for Siemens EDA. So we are in the heart of the semiconductor industry, enabling them with the tool chain and the knowledge to develop the semiconductors, which is driving the AI wave we are surfing on at the moment. I arrived yesterday in Armenia. I was very impressed about your country. And even today, if you compare your event to others in the world, you're doing great. So let's see where this goes today. I'm excited to share a bit our vision and what we are doing and how do we see the industry and what's coming. I think we have a bright future in front of us, being all in technology, and I hope we have constructive discussions today. So you might have seen that semiconductor is changing the world, and I would like to go a bit more in detail what is the factors and what is happening behind. So if you think about software, everybody is talking about software. And we do believe software is eating the world. Software is everywhere. And the differentiation in products only comes from software. So the times when metal bending and plastic forming really made your products, they are over. All the technology companies in the world, they rely heavily on software. And you know what? Software needs hardware. So hardware is feeding the software, which is defining the end application. Data is driving it. So if you look into what is happening in the world with the amount of sensors which are collecting data, and then of course with the transmission needed, if you look into a modern factory, there are thousands, even millions of sensors producing data, communicating over wireless technologies, 5G, maybe 6G in the near future. And then there is process centers which are processing this data. So the amount of data is exploding at the moment. This is really an E function and it's growing so rapidly. If we take a look into the semiconductor industry and the prediction where it will go, then we see that by 2030 it will hit $1 trillion market, which is tremendous. The growth is enormous in all areas. So there is not one little sector which is driving it. It's really coming from wireless communication, from automotive electronics, from industrial, from data centers. Every area in semiconductor is growing. And also, the complexity is growing. If you look into what is happening, Moore's law is not at an end. So we see that the number of transistors is still heavily growing with the next node, but also things like 3D IC are kicking in. That means we are combining different chips into a chiplet and then with that into a package. So the complexity is exploding there. Also the end application complexity. If you look into devices you are using in your daily work and daily private life, they are getting smarter and smarter, more connected. And that of course means more complexity. And also the system complexity. So how they all work together as a system, as an end application, this is growing. So that means there is a gap. So if we look into what we are capable to do at the moment, and also in the past, as well as what we are predicting what will happen in terms of the acceleration we see in the market, the competitiveness, the companies are against each other, we're seeing there is a tremendous gap of what we are able to deliver and what the market is forcing us to deliver. And we call that the mind gap. So this gap is mainly about capabilities, but about, of course, about human engineering power, because that's the limiting factor. If we look a bit more in detail into that, so you see here an example of a 1 trillion chiplet to be done by 2030, and I think this prediction is very, very near. And we see that in this study, in the US, we have 27.3K missing engineers to do something like that. So we see all over the world, also in Central Europe, Northern Europe, that the number of engineers needed to develop these complex things are not enough. Schedules are not held in, projects are delayed, getting more expensive because of the resource need and the delay there. So, to summarize, the society is demanding, and there is an ever-increasing demand on semiconductor. On the other hand side, what we see is that the volume is ramping up heavily. There was never a time where so many semiconductors have been in end products. The cost for semiconductors are exploding. On the other hand side, the schedules are really skyrocketing. And there is one dilemma. The universities are not bringing enough graduates to the industry. And at least when I'm normally presenting, a lot of the audience is already in an ageable stage. So there will be a lot of retirement in this industry on top. So summarizing, there is a gap and a requirement which we need to address by technology, by processes, and by platforms in order to be able to keep up with the market demand. And if you look into what is happening with AI and how AI is changing the world, it's not only that if you look on the left-hand side on this chart, this shows design starts which are including AI capabilities in semiconductor devices. And you're seeing that over the next years, nearly every design will have AI capabilities built in semiconductors. And on the other hand side, we need more algorithms, we need more mechanism to optimize systems, and we need to enable more generalist engineers to do specific tasks. And with that, we do believe that AI is not only changing design, is also changing how designers work. It's actually changing designers. We at Siemens, we also, of course, have a huge and broad AI strategy. In the larger Siemens, we have over thousands of engineers working in this topic. And we at Siemens EDA, we identified for our EDA technology essentially 3 areas where AI will play an essential role. That is adaptive AI, so we make existing tasks more efficient. So reduce the time which we need to do with an engineer from hours to minutes, from weeks to maybe hours or days. The second piece is adaptive AI, where we introduce new methodologies, new capabilities, new processes. So we do things completely different to be able to solve problems in a different way, a lot more efficient. And then, of course, there's the assistive AI, where we say we optimize the design. So we use AI and machine learning to come up with a better result in shorter time. But what is very important if it comes to AI, I think you all know large language models, and they can get creative. So you ask them a question, you get an answer. The underlying thing is that they believe they are right. And you might, if you played a bit with AI, you can get them on thin ice where they start to say things which are maybe not true. So what is very important? We need to enable our engineering community to easily verify what is produced by AI, because otherwise we would create end products which may have a fault inside. So in Siemens EDA, our efforts is really to have robustness, domain expertise, usability. It's all about closing this mind gap and being more productive. Here's one example. It's about our emulation technology, where we use this for verifying designs. So that means if you are creating a hardware description of a semiconductor, you need to simulate that. And at a certain moment, your simulation power is not sufficient enough anymore, so you need to emulate things. And emulation can be a long and time-consuming process, especially the mapping of the hardware description to the emulator. And what we did here using AI/ML technology is we really speed up this process. So we got 100 times of efficiency increase in this mapping and calculation process. And this, I think, is a perfect example. So it's not eliminating the engineer. It's really about making them more efficient and bringing them into the situation that they can solve a certain problem. Also, another example is the Aprisa AI-optimized design space exploration. So if you think about place and route, that means you're going to really define how your end semiconductor product look like, and you place a lot of macros, which are sub-functions of the overall SoC or ASIC, this can be a very time-consuming process. So how do I place all the sub-macros to come to an end product which is meeting my PPA, so performance, power, and area requirements? And there can be applied very smart AI technology to come up with a better result in shorter time with a less need of resources. This is a very resource-intensive process because a lot of computing power is needed to do these calculations. This is my last slide on what Siemens EDA is doing. It's a few testimonials on other areas. What I wanted to say with that is AI is not coming, AI is there. So a lot of investment is in this area. Like I said in the introductional, 80% of the companies are already heavily in AI, and we as well. And especially the semiconductor industry. If you think about what EDA means electronic design automation. We are really used to that since the beginning. Because what we did was always automate manual processes, make them more efficient, and enable engineers to develop more complex technology. So, is the EDA industry making itself obsolete? Are we going to disappear? Let's see. What we see here in this chart is the engineering months needed for a particular design in a particular node. So if you look into the technologies 28, 22, 16 nanometer, the amount of engineering time was overseeable somehow. It's already a lot, but we saw with FinFET, so with the introduction of advanced technology, we saw a real explosion of design complexity. And what we see now, AI is helping us to get control of that. So we are trying, with applying AI technology, bring it down from an engineering time. But it's not going away. The engineers are still needed. And if you predict that, the increase of technology complexity will have a need to get more efficient, to be able to keep up and still deliver products. So this is a little example. I'm not going too much into detail. But what you see here is, the other thing which is important is here the overall cost for developing this design. And without AI, it's cut by 2x. That means this is important. In order to be able to do more designs, we get more efficient, we automate tasks. Another example in the 3 nanometer area, where we see even an increase of the effect on EI. Here's a few statements from some industry experts. I'm not going into detail. But what I wanted to show here is that the industry, the EDA industry, they all believe it's the absolute right thing to introduce AI wherever we can. And it's definitely the case that we need this technology to be able to keep up the pace we are developing more complex products. And in the past, we had many times when there was a moment, a new technology came out, and it thought like, okay, EDA is going away because the problem is solved. But on the other hand side, we see with the explosion of complexity that this is continuing. So to summarize, AI empowers engineers. It's increasing their efficiency. It helps them to get a better resource allocation, to develop a better end product in less time. And if you think about what is chip design is engineers working with smart tools, smart AI-infused, AI-driven tools. It's EDA in that case. And also, maybe another statement, why do we believe that AI is even increasing the number of engineers? So you might have heard that the software engineering demand will go down dramatically with AI. And what you see here on the left-hand side is the complete opposite. So I think massively introduced, it got by 2022, 2023. And since then, in this case, we still see that the amount of engineers, software engineers, is increasing. And that's clear by nature, because what we do with AI is we enable engineers to develop faster and more complex things, but the demand is also increasing on the other side. So don't worry, we will have a job tomorrow. Maybe quickly to summarize, what we see is where AI really has a huge impact, and that's if you look in an engineer starting into a new job, there is quite some learning curve associated to that. It will take time to adapt technology, to understand. And if we compare the both curves, so the red and the white one is one time without and one time with AI, we see that we can accelerate the time we need to bring up an engineer to being productive. And that's clear because we enable him with technology to do complex things without knowing all the details. But it also enables us to, when the knowledge is coming up, to even do more complex stuff than an expert could do before without AI. That's productivity, and that's the way we accelerate with AI. So real quick, I'm going to end very soon. If you look into an IC design cycle, and I choose that example because I truly believe that in Armenia there's also a nice opportunity to further grow your semiconductor industry. There is certain pieces of the IC design cycle which takes 3 to 5 years with or without AI, which are very labor intensive. And especially the functional verification piece is an area where a lot of human power is needed, a lot of technology is needed, as well as a lot of knowledge. So that's an area where I truly believe there is still a lot of demand in the market which is not fulfilled yet. So with that, I would like to thank you for your time this morning. I hope you found it interesting, our view on what's happening with the semiconductor industry, how it will develop. I truly believe that we are in the beginning of an explosion of data, an explosion of connectivity, and that will be all driven by AI. And I truly also believe that in 5 years from now, we will not talk too much about AI anymore because it will get mature into our daily life. Thank you very much.